Welcome everybody. Welcome to Cisco Live. The third day, Wednesday, the day of the party. I hope you're all excited to get to the party tonight. Everyone has his wristband collected. But before that, we have to talk about Nexus Dashboard, right? So it gets some kind of interest if you're in my session. So before we get into it, let me quickly introduce myself. My name is Matthias Wessendorf. I'm a principal technical marketing engineer in the cloud networking business unit and deal there primarily with with fabric architectures and day two operation, and there with the topic Nexus Dashboard. So let's talk about today how we are going to deploy a Nexus Dashboard into our organization. What kind of considerations do I need to do to efficiently deploy a Nexus Dashboard and operate the services on top of it? So if we look for this session, there is a WebEx Teams room. So you can join via the Events app. And from the Events app, then you're getting to the room. This room is monitored till the 17th of June. If you have any questions, etc., just feel free to post them there. We're going to get back to you on that one. During Cisco Live, there may be some delay for this because there is a lot of stuff ongoing, but we will get back to you in the rooms when you ask questions. There are multiple people monitoring it. So you can ask questions there. Feel free to join and join the discussion. Let's have a quick look at the agenda for today. If we're looking at the agenda for today, we're going to talk about what is Nexus Dashboard a little bit, what is the evolution of it, what is the use case of it. We're going to talk about the Nexus Dashboard under the hood. What is Nexus Dashboard really? And then how do I deploy it in my organization? So how do I configure it to serve my purposes? So at the end of this session, you will be able to define the requirements you need for Nexus Dashboard, for the services, if you want, how to deploy it, where to attach it. Is it going to be deployed distributed? Is it going to be deployed centralized? Right, all of this information afterwards, you will be able to answer so that you efficiently can deploy it. So let's start and have a look at the introduction for Nexus Dashboard. Nexus Dashboard is an evolution. We started a while back with the Application Services Engine. Who knows the Application Services Engine? A few hands. Okay, good. So that was the product before Nexus Dashboard. Forget about it. Let's talk about Nexus Dashboard. Nexus Dashboard, as the evolution, we started with a pure physical environment. Right? It was a physical server, a physical cluster, and then we moved on towards a virtual version of it. In the first step, a virtual version for the use of the orchestrator, and now also a virtual version for the use of Nexus Dashboard Insights. We support it also in the cloud. Nexus Dashboard in the cloud, not to confuse with Nexus Cloud that was recently announced. Nexus Dashboard in the cloud is the Nexus Dashboard solution for orchestrator use. The idea of Nexus Dashboard is to be that one tool for day two operation. For day two operation, where you enable the services like automation, orchestration, visibility with the Insights application, then the data broker, right, that we see here. We see also the three personas of the Fabric controller, formerly known as DCNM, which is now also hosted on top of the Nexus Dashboard and is called Nexus Dashboard Fabric Controller, that can be hosted in the version for LAN networks, which is the Fabric Controller, which can be in discovery mode as a pure visibility tool, an inventory tool, and in the storage mode to manage MDSs. So the idea of Nexus Dashboard is the one place where these services are enabled and share a lot of different functionalities. If you manage your fabric with the NDFC and create a fabric there, that we do not need to onboard these additionally to the Insights application, for example. that we onboard a site once and enable it for the use with the services. Right? So that this becomes your one place to go for your operation. Even if we're looking into the Nexus dashboard, if we have multiple installations of the Nexus dashboard because of scale, because of HA requirements, because of the distance between the data centers, etc. We enable with a one view, a single view across all of these clusters, across all the services hosted on top of the cluster. So you really have a single tool to go to for day 2 operation. Is it configuration? Is it monitoring, telemetry, insights? Right, so that's the idea of Nexus dashboard, so that we can share all of this information also between all of these services. So if we look, for example, at the physical version of Nexus dashboard, the physical version of Nexus dashboard is quite beefy. We have a lot of RAM, we have really high performance storage. It's NVMe storage built in, which is needed for data intense applications, right? And then on this one, it's always a cluster of three master nodes plus worker nodes, right? We can host the different services like Orchestrator, Insights, or also the NDFC. Also, we're supporting third-party functionality on top of the Nexus dashboard, like an integration towards Splunk or ServiceNow. The virtual version of Nexus dashboard consists of 2 different personas. It's the same OVA, but it is 2 different personas. The one is the application node. The application node is for non-data intense applications like NDO, the Nexus Dashboard Orchestrator, or the NDFC, the Nexus Dashboard Fabric Controller. Then we have the data nodes, which are for data intense applications. The big difference between these nodes, as you see, is the amount of memory and CPUs needed, but also the storage. For the data-intense application, you need to have high-speed storage. So the Nexus dashboard really is that one platform that can be the one place to go for your operations. Right. So you see that we have role-based access, for example, implemented. For role-based access, you have the user view that has nothing to do with the configuration of the Nexus dashboard itself. It's just for the consumption of the services and provide a frictionless navigation. What do I mean with frictionless navigation? You can access all the services via this one UI, even with one view across multiple clusters. Also, we support there the SSO into the onboarded sites. If you use Nexus Dashboard to manage your ACI site, you can directly log in via the Nexus Dashboard into the APIC controller without re-authenticating. We can use the same login information and do that towards the APIC or also towards DCNM or NDFC-based controllers. Then, of course, we have an admin view to completely handle the platform. If we now take a look a little bit deeper under the hood, what is the reason to implement a Nexus dashboard? What value add does it bring to the applications on top? Nexus dashboard is a container-optimized platform. That means we run an operating system which is container-optimized, which is similar to the operating system of the APIC. We have system services for building the cluster of the nodes. Then we leverage microservices, and for the orchestration of the microservices, we are using Kubernetes. We have infra services, which are needed for the dashboard cluster itself. And after that, we have functionalities like Elasticsearch and the applications on top. The good thing here is, like site onboarding, to bring the sites and to have the inventory of the sites is handled by Nexus dashboard, and this is accessed as a shared service by the application on top. So we got rid, for example, from the application that were formerly standalone, from the services like Elasticsearch to be implemented into it, for the operating system to be implemented with it, to be shipped with it, by purely having the containers focused for the application itself and leveraging the shared services. So if we deploy such a Nexus dashboard as virtual platform, we need to take some considerations which persona I have to deploy of the virtual platform. If I run the non-data intense applications like NDFC or NDO, I can deploy 3 nodes of the persona app and host these services on top of it. These three app nodes are the master nodes. Now, as soon as I'm deploying NDI, I have to deploy data nodes. And these data nodes have to be master nodes. If I deploy NDI, virtualized, 3 nodes persona data as master, 3 nodes worker, app persona as workers. Right? So that means when you deploy NDI, it's a total of 6 nodes. 3 data as master, 3 app as worker. The Nexus dashboard itself has 2 interfaces. It has an interface, the data interface and the management interface. The management interface is used to access the Nexus dashboard. The data interface is a primarily communication path of the services on top of Nexus dashboard to the sites. Now, if we onboard an ACI-based fabric to Nexus dashboard, the communication path needs to be there between the data interface and the in-band interface and towards the out-of-band interface. That's always via the data interface. On the Nexus dashboard itself, there are 2 separate routing tables for the management network and for the data network. And the containers select the correct routing table to make sure if there is a default route, they go out via the data interface. If we talk to a DCNM-based fabric, there we have more than 2 interfaces. There's more than just the in-band and the out-of-band like we have in an APIC. We have an enhanced fabric interface, we have a fabric interface, the in-band interface and the out-of-band interface. In that case, we need to have the communication of the data interface of the ND towards the in-band interface of the DCNM. If we onboard an NDFC-based fabric, then we need to have communication between the data interfaces of the 2 ND clusters. Right? So in a nutshell, keep in mind, if you are deploying a Nexus dashboard, the primarily communication path is via the data interface for the services. The management interface is used for all management purposes. Access to the UI, talking to a DNS server, talking to a proxy server. Right? There's one special thing when you deploy a VND into your network. If you deploy a VND into your network and you use NDI or NDFC on top of it, you need to make sure that the data interface has only a single logical uplink. Either it's a port channel, a VPC, or a single link. If we look into the example for I connect it to a UCS Fabric Interconnect because it's a C-series or a onboard or a managed B-series, right? I need to make sure that, as we see over here, I do not use active-active in the ESXi. Because with active-active, it will break the routing table of the ND on the data interface. Because the ND will learn its own IP addresses that are associated to the containers via the other uplink. And the active standby solution of ESXi is also not a solution for this. This is not supported. That will not work because the standby link still forwards into the port group broadcasts. And that will also break the table. So either you use active standby in the case of UCS on the UCS level, where that link really is not existing, where it is a single logical link, or you have just one link. The same, of course, holds true if you attach it directly to a top-of-rack switch. Either leverage VPC, don't do active-active or active standby on the hypervisor level, use a local port channel or a single link. These requirements have also to do with so-called persistent IPs. Persistent IPs are IP addresses that are assigned to containers and stay with these even if they are migrated across ND nodes. We are doing this to minimize the impact of configuration changes to your network. Whenever Kubernetes thinks to reschedule a pod, you don't want it to reconfigure your network for telemetry information. Right? So for these persistent IPs, they are used starting with the NDI version 5.1 when you use NetFlow S-Flow streaming, or you are leveraging NDI for DCNM, NDFC-based fabrics, you need these persistent IPs. These persistent IPs, you define a pool, and these are assigned to the containers by the creation of the application and stay with that application until it is deleted. This makes sure that the telemetry destination is always the same IP, even if it is moved around your environment. These persistent IPs you can either assign to the management interface or to the data interface. For most use cases, it is used at the data interface. And we have here two options. We can deploy the Nexus dashboard with these persistent IPs in a kind of layer 2 HA mode. What does it mean? The IP addresses I use for persistent IPs have to be allocated out of the network of the data interface. Because if it moves from node 1 to node 2, it needs to be the same broadcast domain to make these reachable. We're going to see a new solution that was added with the recent release of Nexus Dashboard, the 2.2 release, that we can have Nexus Dashboard talk BGP to your network and update your network about the location of these persistent IPs. These persistent IPs are easily created in the UI of Nexus Dashboard, where you go via the cluster configuration, service pools, you add IP addresses to it, and if you add these IP addresses, it is without any subnet mask, it's just /32s, but you don't enter the subnet mask. In case of L2 HA, they have to be out of the data interface. In case of L3 HA, they should not overlap with data or management IP addresses. Requirements, mostly for your reference, when you take a look later at the deck, we see what kind of adjacency is needed for the different services and where do we need persistent IPs. For example, if you leverage endpoint locator in NDFC, you need persistent IPs per fabric you enable endpoint locator for, right? If you leverage NDI for DCNM, you need 6 IPs in the data network. If you do the same for ACI, we don't need the persistent IPs, but as soon as you enable NetFlow, you need persistent IPs. Right? The L3HA really is a solution to this, that you don't need to have any kind of L2 adjacency between the ND node and use, for example, NDFC. The latest NDFC release is fully supported now with these L3HA. In the case we configure that one, each ND node will become a BGP speaker. It is peering with your network and is updating your network about the persistent IPs that are local to that node. So your network knows how to reach the persistent IPs. We are not importing any routes. Right? We do not modify the routing table. It's just there for advertisement. So with that, you even could deploy your NDFC across sites without an L2 adjacency between the nodes. Now the big question, how do I attach an ND cluster to my network? Our recommended solution for this is to attach your ND cluster to any infrastructure which is not the infrastructure it is monitoring or configuring, because then they do not share the fate. Right? It's like every other monitoring system. You don't want it to rely on the infrastructure it is monitoring. Of course, you will get the notification that your network is down because your monitoring system is not working anymore. So any impact there will break the cluster, as we need communication between the nodes. For all of these functionalities like Insights, Orchestrator, NDFC, the Fabric Controller, you need IP reachability to the in-band networks, as we saw in the beginning, of the different fabrics. Right? So IP reachability sufficient from Nexus dashboard cluster towards the infrastructures it is monitoring or managing. It is fully supported to connect an ND cluster to an EVPN fabric that is managed by NDFC, to a VPC-based fabric managed by NDFC or DCNM. Right? All of that is fully supported, but it's not our recommendation due to the facts we spoke about. Don't share the fate. ND, in contrast to the application services engine, is to the network a simple host. There are no specialties needed for this. Even the redundancy of the interfaces what we're going to see is taken care of within the ND and not relying on the network. Same holds true to an ACI fabric if you connect it directly to an ACI fabric, but keep two things in mind. If you attach it to an ACI fabric, please attach it in the management tenant and in the in-band VRF, so that you do not have to do any kind of route leaking between the ND and the in-band network, because remember, ND needs access to the in-band network of the fabric. Right, so deploy it in that one, and please don't put it into the in-band BD and the in-band EPG. That does not work. It has to be in the same VRF, but it has to be a different subnet, a different L2 domain. That's the consideration of the ACI fabric, and both have in common connecting it to an ACI fabric or a DCNM-based fabric. You need to provide, if you have multiple sites, the routing through that network to the in-band networks of the other fabrics it is managing, right? So let's summarize a bit the difference of the pro and contra of connecting it to any networking infrastructure. Or to an ACI or NDFC infrastructure, sorry. So the pro, of course, is it is an easy connection. If you just manage a single fabric, you do not need to take care of routing, you don't need to create an L3 out, for example, for the in-band management, etc. But the contra is, it is really tight, attached to this one fabric. And with that, they share the fate. If we look at, if I'm attaching it to any infra and make IP communication possible between the sites. The pro, of course, is you do not share the fate. Your monitoring system will be available when you have a problem in your system. You have the same communication path to all the monitored infrastructure. There is no need to first troubleshoot why is this different in this way. Contra is, of course, you need to make sure that all of the communication is possible via your potential backbone, out-of-band management network, wherever this is connected then to. So, recommendation, best practices to that one, do not connect it directly to an ACI or NDFC-based, DCNM-based fabric. Do it via any networking infrastructure because of the points I just highlighted. Don't let it share the fate. Because the problem will be, if there's a problem in your infrastructure, it will potentially impact the ND cluster. Because the ND cluster itself is a 3-master setup. As long as you have 2 masters up and running, the cluster is functional. But if you break the whole communication between them, then they go into read-only mode. You can't handle it anymore because we do not have majority of masters anymore. Now, this is, of course, very interesting for the use case of NDO. How can I do redundancy for the orchestrator, for the multi-site orchestrator? Right? What can I do? So I can, if I deploy my ND cluster distributed across multiple sites, I can leverage the concept of a standby node. What is a standby node? A standby node is a node which purpose is to replace a failed master. So in case you have only 2 sites and you want to distribute your ND cluster hosting NDO across these 2 sites with 3 nodes, there is never a full redundant deployment, right? Because if I lose site 1, 2 masters are gone. Now, with a standby node, I can instruct the standby node to replace one of the 2 failed masters to make the cluster operational again. This is an additional level of redundancy for the use case of NDO on top of ND. Right? Because NDO is most likely being deployed distributed. Now, if we take a look centralized versus distributed. When do I deploy an ND cluster centralized? What does centralized mean? Centralized means I place all of my nodes as close together as possible. Potentially all in a rack with 2 9Ks upstream. Now, this is our recommendation for ND, NDFC, if it is for NDI and NDFC, and for NDFC if it is a single-site deployment, right? Because for NDI, there is one thing, redundancy-wise, you're not gaining something to distribute it. You're just giving it the chances to break because you have more points that can interrupt the communication between the different ND nodes. Right? So because if the IP communication on the data interface is interrupted between them, applications, data-intense applications like NDI will stop functioning if it's more than 2 nodes down. Right? So also you need to keep in mind for these data-intense application like NDI, you have a ton of replication traffic between the different ND nodes to keep it in sync. Also, for the traffic path of the different telemetry traffic into the ND cluster, it is always using the same path. Because even you deploy the cluster across 2 sites, right? You do not ensure that all telemetry traffic of switches inside 2 is sent only to the ND nodes inside 2. There will be traffic also sent across to site 1, to nodes across to site 1, and then you have crosstalk to replicate all of this traffic. So our recommendation for NDI, NDFC is do it centralized if it is a single fabric. If you have NDFC managing an EVPN multi-site fabric, you can deploy it distributed with the new functionality of L3HA. Because before that, you would have to have L2 adjacency between the nodes. For NDO, the requirement really is deploy it distributed, stretched, so that you have the single nodes of the ND distributed across the sites they are managing. Right? That's the reason for HADR for NDO. Before I go in deeper details on that one, are there any questions on this so far? Perfect. So let's have a look into the deployment options for the ND. See, when I use this application, that application, what kind of deployments can I do? Before we get a little bit more into that in detail, let's define what is a site. A site is a geographical location which can have one or more fabrics associated to it. We have round-trip requirements for the ND platform plus the applications on top. The ground rule here is it's always the lowest common denominator. So if we look at the ND itself tolerates 150 millisecond round-trip time between the nodes. NDI does only tolerate 50 milliseconds between the nodes and 50 milliseconds from the node to the fabric. So in that case, of course, the numbers of NDI are relevant, not the numbers of ND itself. NDO supports 500 milliseconds between ND and the fabrics it is managing, 150 milliseconds between the ND nodes hosting NDO. And in case you use NDO for DCNM-based fabrics, we tolerate 50 millisecond round-trip time. So if you deploy a cluster with NDI and NDO, the numbers of NDI are key. NDFC itself, 50 milliseconds between the nodes, 50 milliseconds to the fabric it is managing. Now, for the deployment requirements, when we look into you have more than one site, the first thing is the scaling of these sites are dictating how many ND clusters you need. If you run NDI and you have two fabrics with 300 switches each, we can't do that with a single ND cluster for NDI because the limit is 500. There is a cluster sizing tool on Cisco.com. I'm going to post the link in the chat room where you can tell us, hey, I want to deploy a physical ND cluster, I want to deploy a virtual ND cluster, I want to enable the following services, and this is my scale, and the system comes back with how many nodes do you need. So first thing is the size and the applications and combinations is really dictating how many ND clusters you need. Second step, which services have which requirements for the HADR of the system. NDO should be deployed distributed. NDFC for multi-site should be deployed distributed. If it's for single site, centralized. NDI can be distributed, but in general, you should think of having it as close as possible to the telemetry source, because you may not want to pay your service provider all the money for the replication traffic when it's not needed. Because also, with this distribution, keep in mind, you should limit the number of points of failure between the ND nodes to make it really robust, so that not anything in the wide area network is interrupting the operation of your tools. When you distribute it, keep in mind they can be in different IP address ranges. L3HA, L2HA. There you need to take the consideration, do I want to run L3HA? Do I want to use the BGP capabilities if I need persistent IPs? Or am I good with L2 stretched mode if I want to do that, right? Also, if you attach your cluster to an ACI multipod fabric and distribute it across multiple pods, keep in mind the IPN can have an impact into your operation of the cluster, but also you broke my recommendation, do not attach it to your ACI fabric directly. Fully supported, but it is giving you more, or it's exposing the cluster to more potential points of failure. If you run an ND cluster in a multi-site environment, keep in mind that the management tenant cannot be extended via the multi-site functionality. So you need to make sure that this communication out of the in-band network is going via an L3 out and it cannot go via the ISN. As I said, data interface IPs on the ND, please, if it's connected to an ACI, don't put it into the in-band EPG of the ACI fabric. NDO, as an application, as explained before, standby node, I can leverage a standby node to recover even two failed masters. That was implemented explicitly for the NDO functionality. So in that case, you can bring up a cluster, again, up and running, if you lost two masters without data loss. That's doable via a CLI command, completely documented in the user guide. So with that one, then after you brought the standby up, you can add a third master to have a full redundant operation again. So this is in contrast to the MSO operation before, an added level of redundancy with the ND and the standby node, because MSO before were only 3 nodes with no standby node capability. Now let's look at different options for how do I deploy a cluster to my network. This is purely talking about where do I place the cluster? Do I place it in one site? Do I place it in multiple sites? It is not talking about where do I attach it. Where do I attach it again? Directly to the fabric or to any infra and having IP reachability. So in a single site setup, that's pretty easy with a single fabric. You deploy it in that one site and just have IP reachability to your fabric, you're monitoring, you're managing. You're below 500 nodes, so a single cluster works. The amount of nodes, how many workers you need to add to the cluster, depends on the overall size. At the end of the day, you can get via the calculator. In the option 2, it's starting to become a little bit more interesting. You have two sites with one fabric each, and you are below 500 nodes. You only want to deploy NDO. That means scale-wise, a single cluster can handle that setup. Now I have these two options. Either I deploy the ND cluster in one of the single sites and have all telemetry traffic being streamed across to this site, to that one location, or I deploy it distributed. In this case, our recommendation really is deployed at one single site. Even you may now tell, hey, but I stream then all my telemetry traffic across my wide area network from site 2 to site 1. If I do it distributed, it will be streamed also to site 2 already, and I potentially have less traffic crossing the wide area network. This is partially true. First of all, you cannot control which switches are streaming to which ND nodes. So it could be that all switches in site 2 already stream all traffic to site 1. But then you get, as an addition also, the synchronization traffic between the ND nodes as an add-on, which is much bigger than what the telemetry streaming traffic is. So our strong recommendation here is to place it centralized with NDI in one site and stream all traffic into that direction. That will also make your life easier, because any problem in the service provider connectivity between your sites will not impact your operation. If we now look at this option and you are using NDO to manage these two sites, what do I need to do then? So our recommended solution here is have one cluster for NDI, use it centralized at one site, and leverage, for example, a virtual Nexus dashboard cluster for NDO and distribute it. Federate both to have a single UI. Because with that use case, you are satisfying the requirements for HADR of the NDO functionality, plus you have the recommended deployment for the NDI installation. There are two fully supported options as well. You can deploy NDI and NDO together on one centralized cluster. Will work, everything will function, but if something is happening to site 1, your NDO is gone as well. You could do a stretch cluster with NDI and NDO. This is satisfying the requirements of the NDO for being distributed, but it is not the recommended deployment model for NDI because of traffic flow, because of exposure to failures between the nodes. If we look at two sites with more than 500 nodes, with NDI and NDO, there is no way around of having a single NDI cluster per fabric, because you exceed the scale of a single node. And then you can also add the virtual Nexus dashboard cluster and make a federation between all three of them to have a single UI. Or you co-host the NDO with all the consequences, HADR requirement-wise, on one of the ND clusters. Right. So if we look into the summary, how do I plan a deployment for a Nexus dashboard cluster today? The first thing, of course, is I need to make up my mind, which applications do I use? Second is, how many sites do I have? And what is the scale of the sites? Based on that, you can do the sizing and the placement of your nodes. Then we need to keep in mind, how do I attach it? What kind of communication passes do I need to enable? Because these do not change. These are irrelevant of, is it a stretched or a centralized cluster? Is it a NDO, NDI, NDFC? Because all communication is via the data interface, and we need the IP communication. Right? That is the way how you today plan for a deployment, for an effective and recommended deployment of a Nexus dashboard cluster. So, I guess we had an interesting ride for this session. Are there any questions on it? Please.
So if I deploy 3 DAP nodes, as we're migrating
So the question is, if you start to deploy a virtual ND cluster with app nodes for NDO, and later on you want to add NDI to the picture on that same cluster, remember, NDI has the requirement, the master nodes need to be data nodes. For only NDO, it's okay to be app nodes. You have to add the data nodes as standbys and replace one master by time, and then re-add 3 worker nodes.
For the virtual nodes, I noticed that it has to be SSDs with NVMe. Do you have any IOPS requirements?
So the question is if there are any IOP requirements for this one. We have some of these requirements. We tested. I can share them in the room for the documentation. I don't have them on top of my mind. Because the problem is if you go below enterprise-grade SSDs, NDI will fail. It's purely for NDI. Because there's a lot of traffic with Elasticsearch and all of this pipelining that needs to be synced. That we need really fast storage. That's the reason there is an NVMe, a physical NVMe disk in each ND node if you buy the cluster. Please.
If I have an existing multi-site PCI fabric system that start to exist already, I'm using APIC to manage it. If we were to implement NDI and NDO, would that be the single pane of glass to manage the both, or replace, or kind of use instead of the APIC?
So the question is, if I have an existing ACI setup, 2 sites, which are individually managed by the APICs, like single individual fabrics. If I add ND with NDO, is that the single pane of glass, a single configuration across these 2 sites? Yes. The management, yes. The NDO can be used to manage these sites and also extend it.
If someone has Nexus dashboard in the site and looking for FSO deployment, in that case, can it be built from FSO just add and compliance and utilize Nexus dashboard in the site? Is that possible?
So the question is more around, okay, so I want to leverage insights and use information from ThousandEyes and AppD to be integrated in that. In a nutshell, yes, that's possible. This is something which is more belonging to the insights question instead of the ND, but that's possible. You have a plugin to AppD. Okay, cool. So while we are wrapping up, because time is up, please let me know how I did. Please give us feedback that we know what we need to tune for the sessions. Continue your education, especially with the new announced educations for, like example, CCIE for DevOps, etc. Right, that's the best way to learn and train and certify for this. Also, visit us for ND demos, NDFC demos down in the Word of Solution. Book MTE meetings, etc. And I really have to say thank you for being my guest today. And I hope you're all going to enjoy the party tonight. Thank you.